Starting with our course for the IB Mathematics standard level, it's important to have the concept of linear equations as it is the base of our course. It's considered as a previous knowledge in our guide. So we have to know how to find the midpoint, the distance between 2 points, the gradient of a line, and finding the equation of a straight line. So we can start now. Let's say I'm drawing a line. I'm having this line. For this line, I'm having 2 points. The first point is A and the first point is B. A has the coordinates x1 with y1 and B has the coordinates x2 with y2. To find the midpoint, which is here, it's M. To find the midpoint, simply the formula of the midpoint is we have to find the average of the x coordinates, which is x1 plus x2 over 2, with the average of the y coordinates, which is y1 plus y2 over 2. By this we can find the midpoint. Now, if we want to find the distance AB, simply we substitute in this formula. Distance AB is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. This is the distance formula, and this is the formula for finding the midpoint. Now we have to continue for any line drawn. It's really important to calculate the gradient, which we write it as a letter M. The gradient of the line represents the steepness of the line, which is how much the line is steep, or how much is it inverted from the horizontal line. So the gradient, if we want to calculate the gradient, we have to know the change in x and the change in y. So the gradient is equal to the change in y over change in x, which is equal to y2 minus y1 over x2 minus x1. If we're having now a horizontal line, this is my horizontal line, and I'm having other lines as well. This is another line, and again another line. And we want to find the gradient of these lines. The gradient of the horizontal line is always equal to 0. Why? Because the gradient is equal to the change in y over the change in x. For a horizontal line, the change in y is 0. Over any change of x, it gives me a 0 value. The more we go more vertical the line, the gradient increases. So let's say this is L1, this is L2, and this is L3. The gradient of L1 is less than the gradient of L2 and is less than the gradient of L3. If we have a vertical line, this is our vertical line here, and we want to calculate its gradient. To calculate the gradient of this vertical line, simply the gradient is equal to change in y over the change in x. We have a change in y here, but the change in x is 0. For a fraction having a denominator of 0 or dividing any number over 0, we'll get an undefined value. Undefined value, which is in the calculator or your GDC, it gives me an error. Let's check on the GDC. Let's try, start it. Let's try 22 over a 0. This will give me an error. Enter. This is an error by the GDC. So the gradient of the vertical line is undefined and the gradient of the horizontal line is 0. As we go more vertical, the gradient increases. Now we can go to the equation of the straight line. Equation of straight line. To find the equation of straight line, we need two things. First, we need a point on the line, and secondly, we need the gradient. The point on the line, let's say this is x1 and y1, and the gradient is any gradient. If we have the point and the gradient, we can find the equation of the straight line by simply substituting in this formula. Y minus y1 is equal to m, which is the gradient, times x minus x1. Simply we substitute the y1 here, the x1 here, and our gradient here. And by this, we can find the equation of any straight line. Forms of the equation of straight line. Equation of straight line has two forms. The equation of straight line has two main forms. The first form is the gradient intercept form, which is we write it in y equals mx plus c, where m is our gradient and c is the y-intercept. The second form is the general form. The general form, we can write it either in this form, ax plus by plus c is equal to 0, or we can write it ax plus by is equal to c, where a, b, and c are integers. The last thing to know is to compare the gradients of parallel lines and perpendicular lines. Let's say we have parallel lines. Parallel lines, if we want to draw two lines, they have to be parallel. This is line 1, and let's draw line 2. This is line 2. Yes, this is line 2. So this line is parallel to this line. Let's say this is L1 and this is L2. If the lines are parallel, then their gradients are equal. M1 is equal to M2. As simple as this. If we have perpendicular lines, for perpendicular lines, this is my first line, and this is my second line, and these two lines are perpendicular, which means they make a 90 degrees to each other. This is line 2 and this is line 1. So if we take the gradient of line 1 and we multiply it by the gradient of line 2, we get a value of -1. So simply to find the gradient of line 2, and we have the gradient of a perpendicular line is equal to -1 over m1. We flip that value and we change its sign. That's enough for now. Now we can go to solve an example, which is taken directly from the question bank. Let's say this is our good example. We have the coordinates of point A are 6 with -7. The coordinates of point B are -6 and 2. And the point M is the midpoint of AB. L1 is a line through AB. and L2 is perpendicular to L1 and passes through M. Part A. We have to find the coordinates of the midpoint. Midpoint is easy to find. Simply we take the average of the x values and the average of the y values, which is 6 plus the minus 6 over 2 with minus 7 plus 2 over 2. So the midpoint now is equal to 0 with minus 5 over 2. This is our midpoint. Part B. We want to find the gradient of L1. The gradient is the change in y over the change in x, which is 2 minus the minus 7 over minus 6 minus 6 is equal to 9 over minus 12. To simplify it more is equal to minus 3 over 4. This is the gradient of the line L1. Part C, section I, we need to write down the gradient of L2. The gradient of L2, the line L2 is perpendicular to line L1. So we take the gradient of line L1, we flip it and we change the sign. So the sign becomes positive and we flip our fraction, becomes positive 4 over 3. This is C, section I. Now let's go for C, section I. Write down in the form y equals mx plus c, the equation of L2. This form is called the gradient intercept form. Do we have the gradient here? Yes, of course we have the gradient. This is our gradient. Is plus 4 over 3. Do we have the y-intercept? Yes, this is the y-intercept because the line L2 passes through the midpoint. We have a ready y-intercept, so we can directly apply in the formula. So for C, I, y is equal 4 over 3 x minus 5 over 2, which is the y-intercept. By this, we've covered the previous knowledge needed for linear equations to have a good base for our coming mathematical standard level course.